Hi, Professor. Are we playing ping pong today?
Hey students, no, we're not going to be playing any ping pong today. What we got here are some combs, some plastic combs. We've got piles of confetti. I put some out there for you. We've got some ping pong balls. And now what I want you to do is pick up your combs, everybody. Pick up a comb and try to pick up some confetti without actually touching it. Can you do it?
Like a magnet?
Yes, exactly, like a magnet.
It won't happen.
A comb and confetti don't attract one another.
Well, maybe your comb needs to be charged up a little bit. Maybe it needs to be cleaned. So we're going to clean it really good by rubbing it against this wall. And press really hard and really fast. Now let's see what happens.
The paper clings to the comb.
Yeah, it sure does. Now, take the comb and pass it over the ping pong ball and see if it'll follow it.
Gee, Professor, it really works.
Well, all right, students, why do you think this happens?
Because something in the cloth made the comb magnetic.
And that's what we're going to explore today on Science Fundamentals, Static Electricity or Electrostatics. Charge! So, how did we make the comb act like a magnet?
You did something with that cloth.
Well, what kind of material is this? Do you know?
It's itchy wool.
Right, wool. Some materials like wool can cause other objects to become electrically charged. Now, running the comb through your hair a few times, providing it doesn't have a lot of hairspray or gel in it, will cause the comb to become charged as well. Now, this electricity is called static electricity, or electrostatics. Now, let's demonstrate with this balloon. All matter is made up of atoms, and these atoms are made up of tiny charged particles called electrons, protons, and neutrons. Now, electrons have a negative charge, protons have a positive charge, and neutrons don't have any kind of charge at all. Now, when they're balanced out, objects are neutral or uncharged. They don't go around generating electricity. When two different materials come into contact, for example, our wool against the comb, the electrons may be transferred from one material to another. Now, another way to explain this is if one material ends up with an excess of electrons, it becomes negatively charged. An accumulation of unbalanced charges results in the phenomenon called static electricity. Now, if two materials have imbalances of opposite charges, the materials will begin to attract each other and cling together. Now, if they have imbalances of like charges, the material will repel or pull away from each other. Now, sometimes this imbalance of positive and negative charges can be enormous, so much so that a spark may jump across space from one material to another. Now, this is what happens when we see lightning. And you ever see it arc across the sky? You've seen it plenty down here in Florida. Now, it's quite powerful, as we well know. A smaller version of this happens if you've ever walked across the room on carpet. Have you ever done that? And you walk across and you shuffle in your feet and then you go up and you touch some metal and you get a shock? Have you ever done that? Well, that's another example of this transfer of electrons. All right, let's do some activities with these balloons. Everybody got a balloon?
Yep.
Okay, everybody got one? Can you put a knot in it? I couldn't do that until I was about 17 or 18, put a knot in the balloon. Can you do it? Okay, now we're going to try some simple activities with these balloons. Okay, now I want everybody to take a balloon, go ahead and take your balloon, and rub it on the cloth, or rub the cloth against it either way, rub it vigorously, and then make it stick to your sweater, okay? You want to try that? Let's do this. Get a good static charge going. Now let's see, it should stick. Voila! Now why did it stick?
The static electricity makes it stick?
Exactly. The electrons rubbed off the wool and onto the balloon. Now the balloon is charged with static electricity. It has more electrons than protons, so it's negatively charged. The wool now has more protons than electrons, so it's positively charged, and so they attract each other. Now, let's charge another balloon with the wool. and hold them next to each other, and let's see what happens.
They move away from one another.
Or they
repel each other.
Yes, they repel. Remember, like charges, positive to positive or negative to negative, repel. Unlike charges, negative to positive or positive to negative, attract. Now remember, electrons are negative charges and protons are
Positive.
very good. Now let's do a few more activities. What I've done is I've taken some strips of garbage bag here, some polyethylene strips. And Kayla, I want you to have that. Pamela, you take this. Jennifer, what we're going to do is we're going to eventually pick them up. We're going to pinch them in the middle and pick them up just like that. Here, you take that one, Junior. And now I've got a little piece of newspaper there, about 2 inches wide, about a foot long. I want you to lay this in front of you, like that. Here you go, Jennifer, Kayla, Pamela, just like that. And lay your polyethylene strip on there. Can you do that? Now I've got some smaller bits of newspaper. Again, it's just plain newspaper. That's for you, Junior. There you go. Now, here's what I want you to do. Jennifer, can you put your finger right there on that, and then take this and rub it one way. Do it about 10 times. Good. Good. Can you guys do that? Do what Jennifer's doing? That's it. Right. Now, pinch it in the middle and hold it up. And what happens? The strips are repelling each other here. The rubbing of the polyethylene with the newspaper caused a transfer of electrons from the newspaper to the polyethylene, resulting in static charge. Now, the two sides of the plastic strip repel because they have the same charge. Now, move your hand in just a little bit. What happens?
It attracts.
Exactly, it attracted. The charged strips are attracted to the uncharged objects, the same as the balloon was attracted to the sweater. A charged object actually causes or induces a localized weak opposite charge on the surface of the uncharged object that causes the attraction. And now what happens when you run the strips through your fingers? Give it a try. The strips lose their charge as our fingers pick up the extra charge, and they move through us back to the earth. So the strips hang side by side again. Most materials are categorized as conductors or non-conductors, depending on how well they allow electrons to move through them. Some material like rubber will not allow charges to move easily, and this material is known as a non-conductor or an insulator. Let's do another activity with our polyethylene strips. Now, Junior, I want you to take this polyethylene strip here and recharge it. Okay, that's good. Now hold it up. Now let's touch this drinking straw to it and see what happens. The strips are weakly attracted to the straw, and when the straw is removed, the strips continue to repel because the straw didn't conduct away the static charge. Now touch the strips with a conductor, such as these aluminum foil strips. What happens?
They attract each other.
Now, how is this different with the non-conductor? What causes that? The metal conductors carry the static charges away, allowing the strips to move closer together, while the non-conductors did not carry the static charges, leaving the strips charged and repelling each other. So what happened when we made our combs into magic wands of sorts? What is electrostatics or static electricity?
It's the accumulation of imbalanced charges when two different substances rub together.
And these charges are?
The electrons and protons are the atom the material is made from.
One loses electrons and becomes positively charged, and the other gains the extra electrons and becomes negatively charged. And remember, two objects with opposite charges will attract each other and exert pulling forces on each other, causing them to cling together. Materials with like charges will repel each other. Some material like wool or hair or newspaper will give off electrons more easily when rubbed. And it'll charge material like the comb or the polyethylene that might otherwise remain neutral. And this, of course, is what's happening with our magic wand and comb. So what do you say we take our ping pong balls for a walk, all right? Static electricity is fun to play with at home. Try using wool, newspaper, or even your own hair to charge balloons or combs or anything else you may think of and see what happens. But remember, always have a grown-up help you with a science experiment. Static electricity and science is fundamental. So have fun with it. See you next time.